Video on functions. I'm gonna try to finish this one within 10 minutes. I'll try my best. So first of all, there are four things I want to go through. First of all, finding the f of x. This is one single function. And then finding two-step functions, which is also known as composite functions, such as finding the f of g of x. And also inverse functions and graph transformations involving functions. Okay? So first of all, let's go through the most basic type of function questions, which are f of x. Okay, this is like the simple function. Let's say f of x equals 3x plus 1. Okay, so what they're basically saying, we're getting a x, a random value, we're putting it into the function, and then the result we're getting is 3x plus 1, where we will multiply the input by 3 and then add 1. Okay? So let x equal 6. So all we do is we sub 6 into the x. We sub the value of x into its place in the equation. So f of 6 equals 3 times x is 6, and then plus 1. Okay, so the f of 6 equals 3 times 16, 3 times 6 equals 18, plus 1 equals 19. So when the f of x equals 3x plus 1, and when x equals 6, we will multiply 6 by 3 and then add 1 to get 19, which is the f of x. This is the output of the function. Okay, this is like easy. This is one-step functions. Now we have two-step functions, composite functions. So in these type of questions, you have two separate functions. Okay, so let's say we have the first function, which is f of x equals 3x plus 1. And then we have the second function, which is like completely independent from the first one. It has nothing to do with it. So g of x equals x squared. Okay? So let's say we put 4, the number 4, into the f of x. We would multiply 4 by 3 and then add 1, getting 13. But if we put 4 into the g of x, we would get 16, 4 squared. So there are two completely different functions. But in the exam, it says find the g of f of x. Okay? Find the g of f of x when x equals, let's say, 5. Okay. So when they say find the g of f of x, what they mean is x has to go through both functions. It has to go through the f function, and then it has to go through the g function. Which one does it go through first? The one closer to the x will be the first function we use. So the f is closer to the x, the one beside it. So we will put the x value into the f function. We will put it into the f function, and the result we get from our f function, we will put it into the g function. Okay? So first of all, we'll do the f of x because it's closer. So f of 5 equals 3 times 5 plus 1 equal 16. Okay, this is our f of x. Now we have to find the g of the f of x. We found that f of x is 16. So now we have to put 16 into the g function. So the g of 16 equals 16 squared equals 216. Okay, so the g of f of x when x equals 5 is 216. Okay, next we have, just let me check. Okay, so next we have inverse functions. Inverse functions. Okay, in inverse functions, this is the simple function. A simple function is just we get a random value of x, we put it through the function, and then we get a new value, which is y. Okay, in inverse functions, they want us to find our way back from the y to the x. So instead of putting x into the function and finding y, we have to find the function which turns y back into x. Okay, so there are more than one step. Please focus because you have to remember these steps. They won't be like on any formula sheet or anything. So let's say the f of x equals x squared plus 5. So any value we put into this function, we will square it and then we will add 5. So how do we find the inverse function? First of all, you write x on its own. Okay, x on its own, followed by the equals. And then you write this, x squared plus 5, but you replace x with y. So any x you find on this side, you replace it with the letter y. Y squared plus 5. Okay, so this comes to here, and the x, we write it alone, and then we write equals after it. Next thing we have to do is, we have to isolate the y. We have to make y alone. Now y is with the squared sign and it's with the plus 5. So let's make it alone. So y squared plus 5 equals x. Next, we get rid of the 5. So it will become x squared equals x. We bring the 5 to this side, becomes minus 5. So now we have y squared equals x minus 5. But still we don't have y on its own. We need y on its own. So what we do to get y on its own is we square root the y squared, and so we will have to also square root the other side. So whatever we do to y, we do to the other side. So y squared to y, and then x minus 5, we also square root it, the square root of x minus 5. Okay? So this is our inverse function. If you don't understand, I'll show you an example where it will make it much clearer. So we said that the original function was x squared plus 5, right? Now x squared, let x equal 3. So 3 squared plus 5 equal 9 plus 5 equals 14. Okay? Now, what if they only gave us the 14? Would we be able to go back and find the 3? Well, yes, we found the inverse function, the square root of x minus 5. So, we put the 14 into this formula, into this equation. Let's put the square root of 14 minus 5. So 14 minus 5 is 9. So equals the square root of 9, which is equal to 3. So the inverse function, we put the answer into the inverse function, and it will give us the original number that we first of all put into the equation. Okay? This is for inverse functions. Now, the last thing, how long is the video till now? Okay, I still have time. Okay, so now we have graph transformations. Graph transformations. Okay. Involved with functions. So, let's say we have a graph, and on this graph we have a curve. Okay? This line is f of x. Okay, this line is f of x. So what I mean is, for every x value, we do a function to find the y value. Okay? This line is defined by the function f of x. We do a function to the x, we get a point on the y, and we make the graph. So, the transformation of the graph. So, let's say, first of all, there are two rules. This is f of x. if we change anything in the brackets, we will be affecting the x-axis. If we change anything outside the brackets, we will be changing the y-axis. So just remember, x is inside the brackets, so it affects the y-axis. And then if we change anything outside the brackets, we're changing the y-axis. Okay? So let's say f of x plus 3. Okay? F of x plus 3. This is our original graph. Now this is f of x. Now draw a line which shows f of x plus 3. So we look, what is the change? The change is a plus 3. Where does the change occur? Outside the brackets. So it's not with the x. So it's a change in the y-axis. It's a plus 3 in the y-axis. This is our y-axis, so it's a plus 3. So for each point on the graph, we increase it by 3. 3, 3, 3, and now we form a new line. Okay? This is f of x plus 3. If it was f of x minus 3, we would just move down the dots by 3 spaces on the y-axis, changing the y-axis, and the x-axis doesn't change. The x-axis doesn't change for the dots. Okay, let's say f of 3x. Okay, f of 3x. Now, what we have to do now, the 3, as we can see, it's outside the brackets. Since it's outside the brackets, it's a change in the, just a second, sorry. Okay. F of sorry. Never mind. 3f of x. So the 3 is outside the brackets, and it's not a plus. 3f means 3 times f. Okay, so what we do is, this is outside the brackets, a change in the y-axis, so we multiply this value of y by 3. We don't change x because the x has remained same. We haven't changed anything inside the brackets. So if it's a plus 3 or minus 3, we increase or decrease the y values, and if it's 3 times or 2 times f of x, we multiply the y values by this number. Okay? This is for the transformations outside the brackets. Now let's move to inside the brackets. So we have f of x. Okay? Let's move into inside the brackets. Inside the brackets, we could have f of x plus 1. F of x plus 1, or f of x minus 1. So what we do now, it's inside the brackets, so affects x-axis. Okay, so if it's x plus 1, we change the x-axis, but there's note, the change inside the bracket is opposite. You have to remember this. This is like really important. You might get many questions on it and many graph questions, and if you get this step wrong, it will ruin the whole thing. So when the change is inside the brackets, we know that it affects the x-axis, and it is opposite. So if it's a plus 1, we decrease the x-axis, and when it's minus 1, we increase the x-axis. Okay? Okay guys, so if we actually draw this out, the change in the x-axis, let's say this is the graph. So if f of x plus 1, we said that instead of increasing by plus 1, we decrease by minus 1. So we just do the opposite. So all the x values here, we decrease 1, it becomes here, this becomes here, this point becomes here, this point becomes here, and then we draw the new graph. As you can see, the height of the points hasn't changed because the change only affects the x-axis. It's inside the brackets. It doesn't affect the y-axis. Okay, so the points remain on the same height but with a different position on the x-axis. Okay, and then two last things you need to know. I don't really have to draw a diagram, it's just telling you. So negative f of x and f of negative x. So when we said a change outside the brackets affects the y-axis and the change inside the brackets affects the x-axis. So when there's a negative outside the brackets, it's just negative f. It's a reflection on y-axis. Okay? And when f of negative x, it's just a reflection on the x-axis. So let's just draw a really quick example. So let's say this is the graph. Here it is. So a reflection, what I mean by a reflection on the y-axis, this is the y-axis. So you flip it around as if you're flipping over the page or something, and it becomes something similar to this. If you're reflecting on the x-axis, you reflect it on this line, so it becomes something similar to this shape. Okay, this is all for functions. We've been through, so finding f of x, finding the f of g of x, composite functions, inverse functions where you go back to your original input, and graph transformations where you have to adjust the line according to what they ask. Okay, this is all, and thank you. Bye bye.